This is a talk about handling errors in Swift code. I'm Jeff, like you said. So about me, real quick, I've been an iOS developer for about 10 years now, pretty much since it came out. I was at WWDC 2008, and I said, that sounds really cool, I should do that. And that's what I did. I spent about a year doing TypeScript, but now I'm happy to be back writing Swift apps. I wrote a couple of books that you should not buy because they're very out of date. This one's about iOS 5-ish, and this one's watchOS 2. So don't buy them. They're very out of date. But in my work at Detroit Labs, where I work, as you can see by this awesome sweater, I come across a lot of code. We write apps for clients. I've probably written a few dozen apps in this time, and I've seen code for many more. And there's a common problem that always happens, is that sometimes an error happens in the code, and then you don't handle it well. So this is kind of a silly example, but when something wrong happens in your app, you have to do something about it. And sometimes the right answer is just to throw your hands up and say, forget this, show something to the user, although hopefully something a little bit more helpful than some hex codes, and quit. So before we go into Swift, raise your hand if you ever wrote Objective-C code. OK, lots of people. So you remember this dance, right, where you'd create an error pointer, and then you'd get a success Boolean from whatever you were doing, and you would store the error in that pointer that you created. If you didn't care, you could pass null. And that's how a lot of code looked. And like a lot of Objective-C, it was super verbose. And most of the time what happened is people didn't handle the error. So let's talk about Swift. Most people learning Swift, this is their first exposure to the error type, as they get some result. This isn't in the standard library yet. My coworker, John Shire, is probably going to submit another Swift evolution proposal to get this in the standard library, now that Kotlin has one. But a result can be one of two things. It can be successful and have some value, or it can be failure with some error. So typically, you're learning Swift, you do some network call, and you get one of these back from the service, whether or not it succeeded or failed. And that's what that looks like. Except you don't actually see the result most of the time. So Alamo Fire exposes this value property of the response, and that actually turns the result into an optional. So all they're doing is, if it's successful, return the value. If not, return nil. And this is actually a pretty common pattern in a lot of code, where you'll get some result back. So this might be some asynchronous thing, like adding samples to a workout in HealthKit. And you perform it, and you get back a result. Could be success, could be an error. But there's a big problem in code that I see all the time, and error handling in general, is that you get this comment, to do, handle error. And then you move on, you have to do something else. Time passes, and it's not until one of your users, or if you're lucky, QA, is going through a tunnel using your app, and the network request that never fails, fails. And you don't know what's going to happen. Anything could happen in your app. So what I'm going to try to do in this talk is convince you that you should be handling errors, not by shaming you with horror stories of things that could go wrong if you don't, but by showing how you can take the errors and make them really cool and make them work for you. This happened in the days of Objective-C, of course. So we'd get this pointer to the error, we do the thing, and then if success, we proceed with whatever it is we wanted to do, and then in the else, we'd have that to do, and that to do would hang out there forever. How's the contrast on that comment? Can you read that in the back? Cool. So here's that same code in Swift, translated from Objective-C. We get this file manager, we remove the item at path, but this won't compile because we haven't called this with try. So this was Swift's grand idea to fix this problem, is they made it so that if a method can throw an error, then you have to handle it. You have to do this do, try, catch pattern. We try to remove this file, and if it fails, then we enter the catch block and we get some error. And we can print it out or do whatever we need to do. So that sounds great. That sounds like a really good solution to this problem, is to force the developer to handle that branch. And if they don't do it, it won't compile. Except they also added these two variants, try and try. And if you use the first one, it will be nil if it's an error, and the second one, it will crash. So obviously, these are no better than the to-do. They will fail in weird ways. And if we want to make it easy for people to handle these errors, if we want people to do it, then we should make it easy. So if you've never written anything that uses throws, if you're new to error handling in Swift in general, you can write these methods yourself. You just put throws right before the return type. If there's no return type, then you just put it right before the brace. And when you're in this method that can throw, anytime you call something that could itself throw, you just throw it the try, and it'll bubble that error up to whatever you're calling, or whatever's calling you. So in these two methods, if delete secret identity fails, or if retrieve secret identity fail, then as the caller of the code, you'll get some error back. And you can chain these too. So if you have 2 or 3 things in a method that could all potentially throw an error, you can just call try on each of them. And then the first time you get an error, it'll send it to the caller. And there's some advanced stuff you can do too. So here we have map, which is a common collection thing most people have used. And this one, the closure itself takes an element, gives you back this T generic type, and it can throw. So maybe you're trying to map strings into integers. And if that conversion fails, then it throws an error. So what map will do, it uses this rethrows keyword. And that's a guarantee from map that the only time it's ever going to throw an error is if what you passed into it can throw an error. So if what you pass into map doesn't have the throws keyword, if there's nothing that happens in that closure that could throw, then it's just like probably 99% of the times you've used map, where there is no catch to worry about, there's no try. If what you pass in doesn't throw, you don't have to put try before the map. And so here's that in use. We get this result, and then we just try the transform on the item, append it to the result, and that's it. So there's a few different classes. There's results, there's errors that you can throw. But how to actually handle them once you get an error. I keep saying you should do something with it, but what is it that you should do? And that depends a lot on the specific error. So the first thing you might do is exactly like that blue screen of death we saw before, just fatal error. And this will just crash the app. It'll stop execution. It'll print out whatever message you pass in. So we'll just pass in the localized description of the error, and then your app is done. And if you have a debugger attached, it can pause. You can kind of try to get some context behind the error. And this is kind of the nuclear option. This is this app should never be here, and it's not safe for us to continue running option of handling errors. But it's better than nothing. It might prevent something worse. Who knows? So you're building an app, and everything is going fine. You're testing it. You think testing is important. And you're handling all these errors. And you have an error that you want to do a fatal error on. And there's one little thing that you can't shake. That stupid red line in this method in your code coverage. Because it's a fatal error. If the test were to call this method with false, then it would crash your test. So there's no actual way to verify in your test that this code works. You can look at it, you see that it calls fatal error, but you don't know that it calls fatal error until you run it on a simulator or on a device and you verify that behavior. Now, I don't know about you. I don't think that 100% code coverage is really a goal we should all be shooting for. Code coverage really only measures which lines in your program ran when it was tested. It doesn't verify that they ran correctly or that they were supposed to run. But that red line, it's really annoying. So what can we do about that? We'll come back to that later. So this kind of throwing error, where you have an actual enum that is an error, and then if you call this method with false, it'll throw this error. This is actually very easy to test, right? So if you come in here, you can do xctest assert or xct assert throws error, and in there you just try passing false, and you can say I expect this method to throw, and you can even provide a closure, and it will give you the error that was thrown, and you can verify that it was the right kind of error. And this is great. If you want to be able to reason about what your code is doing and you want to make sure that this condition produces this error, it's very, very easy to do. We know for sure how our app is behaving. And that's really what I care about in testing. I care about knowing how my app is going to behave in certain conditions. So there's a method that I found on a blog that was copied from Stack Overflow that I really liked, which is you can provide your own implementation of fatal error. And because of the way Swift works, if there's a symbol called fatal error in your code, it will happen, it'll call that before it calls the Swift version. So we can just write this replacement for fatal error. We're going to take a message, and defaults to just an empty string. So I take a file name and a line number so that Xcode can have more hints about where to show you in your code this was called from. And it returns never. And never is an interesting return value. This basically means that if you call this, it's guaranteed that you will never leave this method. And of course, fatal error meets that, because if you call fatal error, your app is done. You're not getting out of it. And in fact, all we're going to do in here is call the real fatal error. We're going to call swift.fatalError. So what's the advantage of doing this? And sorry, this might get a little hard to read on the back, because you need a lot of code to make this work. But we can have this type alias for a fatal error closure that just takes a string and a static string for the file name and a line number. And I give it a default fatal error closure, which is just the swift.fatalError, and the one we defined before. So then in our test code, we can have this replace fatal error and restore fatal error methods. And so this is just going to replace that static block, and then when you call it, it'll do whatever you want, and then you call restore, and it brings back the default Swift one. And you're only ever going to call this from test code. In shipping code, you want the real swift.fatalError if you call fatal error. So now you can test it. So you can make this extension, an XC test case, that expects a fatal error to happen. So again, you've got to give it the file name and line number. This is important in tests so that when the test fails, you see the test failure at the actual test and not here in the code. So you make an expectation saying that the fatal error should happen. And then you replace fatal error with your block. Now, your block still has to be a never returning method. So there's just this unreachable method that just runs the run loop forever. So you do that. You fulfill the expectation, and then you just continue running forever. And then asynchronously, you call that block. And it's important to be asynchronous, because it's a never. So if this was synchronous, then your test would never end. Then you wait for your expectations after that with some timeout, and then when it's done, you restore the fatal error. Now the way that XC test works, if you have any unfulfilled expectations, when this timeout finishes, then it'll fail the test. So if you don't receive this fatal error, then your test will fail. So finally, you can expect that a fatal error will occur when you pass false to this method. And then finally, your class gets 100% code coverage. And even though that is a worthless metric to shoot for, it makes you feel good inside, because you see this unbroken green line on the side, and you know what your app does. You can write a test about it, you can reason about it, and if it changes in the future, you know about it. So when should you use fatal error? I mentioned before that some bad things can happen if you crash. Who here uses core data? Okay, some people. It's gotten better, but it's still pretty fragile sometimes. And one thing you really don't want to do is crash at an unexpected time when you have things going on with a database. If that core database becomes corrupt, then sometimes the only thing you can do is delete it and start over. And that's not a good experience. A pet peeve of mine is apps that don't handle these things properly. I'm sure we've all launched an app, and then maybe there's bad network conditions, maybe a crash happens, and you launch it again. And it's like the first time that you've ever launched the app. It says, "Welcome to our app. Would you like to create an account?" No, I just used it 5 minutes ago. And that really breaks like the idea that this phone is a personal thing. So it really bothers me. So here we have some common code that you might see. And this indentation style here, I just stole that from the standard library team because it's really easy to fit on slides that are packed horizontally. So we're just going to get a table view cell. And we want to dequeue a reusable cell with some identifier. And we want to make sure it's the right class. And if it's not the right class for the identifier, we're just going to throw our hands up, we're going to crash the app, and we're going to go on with our day. And if we get the cell, then we're just going to use that cell. Great. Maybe that's what you want. Maybe it's really, really important to get that cell, and you do want to crash. Probably not. Maybe this would be better, right? So you want to have this crash happen when you're in debug mode. When you're building the app, you would like to know if this fails. But when the app hits the App Store, you would not like to crash your customer's apps just because you couldn't get the right kind of table view cell. That seems like a reasonable thing to do. In fact, so much so that that's another method called assertion failure. So assertion failure will do pretty much the same thing as fatal error for debug builds, but for release builds, it will just do nothing. If we're going to use assertion failure, we need to have some actual return value for this method. So if we don't get the right thing, we're going to call an assertion failure, probably throw some message in there about why we're doing an assertion failure. But then we're just going to return a blank UI table view cell to do something so that the app can keep running. And there's a few different things that you can use. So I made a handy little chart here. So fatal error will always 100% of the time crash. Precondition will crash on production and debug builds, but not if you compile it with the -o unchecked fast option. If you compile it with that, it will just assume that it's never going to be true. So it's a little bit dangerous, but that's what unchecked is all about. And then assert is just for debug builds while you're developing. So there's assert and precondition, and then those also have assertion failure and precondition failure. So assert and precondition, they take some Boolean condition. And if it's not true, then they crash. If it's debug and all the right conditions are met. So if you have a more complex example that you just can't figure out what you would even return, that's when you would use a precondition and crash the app. But if it's something you can recover from, then you would use assert. Now, if you want to test these just like fatal error, then these are also just Swift methods. So you can use that same wrapping technique. Just replace fatal error with assert or precondition failure. And you can get these tested, and they can just run in your code. So we're going to make this a little bit more complicated now. We're going to make this a generic method on UI table view. And it's going to dequeue some generic table view cell with some reuse identifier, and it's going to throw if it can't find it. So what we're going to do is we're going to call dequeue reusable cell with that identifier. We're going to try casting it to that type. And if it doesn't work, then we're going to throw an error. And I really like to name these programmer error, because that tells me that I did something wrong, and that it's not some error from some web service or some mythical part of iOS. This is something I did wrong, is that I didn't have the reuse identifier right, or I didn't meet some condition to be able to produce that cell. So then, when I use it in the actual code, in my view controller or whatever code you have that's producing table view cells, then I can just try this table view dequeue, give it the type, give it the identifier, and if it works, that's great. If not, I can call assertion failure, give it the localized description of that error, and return a blank one, and go on with my day. So another thing you might notice here, trying to make this even better, is I keep passing around this localized description of the error. And I'm not actually localizing it for the user. This is for the developer. This is just a convenient way to get a string out of an error. So we can go a step further. Because I'm just writing this method anyway, I can change the type, and I can have it take an error instead of a string. And so now, when I call fatalError with an error, it will call the one that I wrote with a string, just giving that description out. And of course, you could have variants of this for precondition and assert. So that now all I have to do is call assertion failure, pass in the error that I get from the code, and it will do the right thing. So I think this is a lot better than just not handling the error or than crashing the app. But it keeps me in control as a developer. I know exactly what's happening. It's very testable. I can set up a condition where there is no table view cell registered with that identifier, call it in the test, and see, hey, look, it gives me this exact error. So that's nice. And I can extend our expectation code to take some generic error. And this time there's going to be a constraint that error has to be equatable. And now I can expect not just any fatal error, but I can expect a specific fatal error to happen. And so when I go in my code, the rest is pretty much the same. I don't have the actual slide up here where you use it, but oh, there it is. So I can assert that the assertion error and the expected error are equal. And so that's handy. Now I know exactly which error is happening. It's useful for logging, too. So here's some sample code from a side project I'm writing where I'm adding samples of workout data to a workout. And every time you add these, just like many APIs, you get some success or error back. And what should you do if you fail adding like 3 out of 10 samples to a workout? I don't know. But I do know that I want to log that. And so I have this common logging utility called log. And I found myself in this same pattern again and again, where there'd be an error adding samples to the workout, and I throw in the description. And that kept happening. And they all had the same format, where if there's an error, then have some log message with some context about what I was doing when I got the error, and then the description of the error. So because I like writing extensions on these things, I wrote one that interfaces with the log. And again, giving the file name and the line number so I know exactly where it happened. And some context string. So to say, hey, an error happened doing this thing. Here's the error. And that's where it happened. The type is for the log, to color it right in the log and all that stuff. So now when I want to call this, I think this is much better. I don't have to unwrap it. I just call error, unwrap, and then .log. And it's one line. And the context is just adding samples to the workout. So I know exactly what happened. And all that boilerplate code just lives in one place. OK, so that's pretty much where I am in the state of my error handling code today. But a lot of people on the Swift team have talked about typed throws. And this is something that I really hope makes it in the language soon. So I mentioned, I knew exactly which error my code was going to throw. I knew it was going to throw this exact programmer error. I could test it. I could verify that's how it behaves. But I can't write this. I can't say that it throws this type of error. All I can do is say that it throws some type of error. Which means, even if I want to use catch with a pattern and say, hey, if I get this specific error, do this thing, I still have to have this line down here. Because I can't know ahead of time that this is actually going to return just that error. So I have to handle all possibilities. If I don't, this will fail to compile. And so here, because I know that this code should never reach this area, that's one place you might call fatal error. or you might just call assert, depending on your code, because you know you wrote the thing that it's calling. If you get down to that last catch, something seriously wrong has happened. So when this comes up, when typed throws come to some Swift proposal, we should all go, and we should all give it a big +1. Make sure that it makes a language as soon as possible. All right. Now, don't worry, it's not the end, but I wanted to put in a break here for any questions.
But like a concern, because you showed that we should basically catch error, and in this example, I don't know if it was like a dummy example, that we should basically catch this error and return the UA table view cell like a dummy cell. Because this actually leads you to the situation where you have undefined behavior in the application, and you have no idea what's going on, and you at some point are going to get like really low reviews on App Store in your application, and you don't know what's going on because you didn't crash. So like, honestly, I think that as you like showed here, the programmer error is actually something where we should crash, in my opinion, because like then you have a feedback that you did something wrong, and that's just like a concern I have. And the second thing is like considering like today's architecture for iOS applications, where do you think we should like catch errors and notify about them? Like in which layer of the application we should do it?
Sure. So I can answer both of those. First question is it potentially worse to have this dummy table view cell returned and get low app reviews? Obviously, this is something every developer has to decide for themselves, maybe as a team. The one thing I will say, if you get here, in real code, I'm not just returning that table view cell. I'm going to throw up some kind of message to like an analytics service or something that will let me know as a developer, hey, this actually happened in the field. You should look at this. There are some libraries you can use that might include like a screenshot if you don't have any personally identifiable creepy information on the screen. That could be helpful. You know, depending on what type of app you have. If it's a banking app, you might want to be a little more strict. If it's just like some silly game, then it doesn't matter as much. So it's entirely up to you as a developer, and fatal error sometimes is the right thing to do, and that's fine. Now the second question, as for where is the right place in the app to handle an error? If you didn't go to Paul Hudson's talk today about coordinators, it would dovetail in very nicely. So I use coordinators in my apps. The sample app I mentioned with the health kit thing, it's a watch app. And watch app UI, it's kind of frustrating to work with sometimes. And so I have a coordinator that can do things to move screens around. And one of the things it can do is report an error to the user. So this is a programmer error, right? That's something for me. But I also have in that app an enum, which is user-facing error. And that will actually have associated with it some string to show the user. So when I get an error that should be user-facing, I tell the coordinator about it. And then the coordinator knows how to present an error dialog to the user from there. Obviously, not every error is one that you're going to show to the user. If it's, you have 100 samples to save to the workout and one of them fails, you probably don't want like a dialog coming up for every one. But things like, I couldn't save the workout at all, that's something I would tell to the user.
I was doing errors in Objective-C, probably as everybody. And there was the user defaults where you can define the as localized scripts, localized description, and also some other keys like failure reason, whatever. There was some other things. What about those? In the localized description, you don't get those, and still like file manager has those, it throws those. So you got actually the more information in that, and the localized description in don't print it. Are you deliberately omitting that, or I mean, just asking for like what's your preference and why localized description only?
Here I'm just using localized description as an example because it's easy. There is a type of error called localized error, and that has things like, I can't remember the names, but there's more string descriptions. There's like a recovery suggestion. So all the things from NSError that you were talking about, most of those live now in localized error. And one thing you can do with these catch patterns is you can write catch is localized error. And then if it is one of those and it has that more information, then you can process it there and pull that information out. I think you can also just pass a regular NSError, which is likely what a lot of Objective-C APIs are still doing.
Okay, I really liked the way you dodged the crash on the production with the QE.
Thanks.
And this reminds me of a situation when I had to deal with some legacy code, and we had really a little bit crappy situation with outlets. We had a lot of lost references to the outlet, and in that case, to run the application on a production, we decided to make all of them optionals. But this ran us into this situation where user was able to run the view, but we had no feedback about the lost references. And I wonder, have you ever run into this kind of situation? And have you any kind of concept how to deal with this kind of losing references? Because it's quite similar to this dodge the crash with the queue, but we've got the outlets, so we are unable to catch that the outlet is not connected there, and the optional is just making us is allowing us to present the view, but we have no feedback back to the programmer how to deal with this.
Sure. So it depends on how strict you want to be. I'm also the same way. I'm kind of unusual in that all of my outlets are weak and optional because you never know for sure that they exist. You have a good idea that they're going to exist, but they might not. And so one thing that you can do is have like a UI test that can cover most of the app flows. Using UI tests will cover a lot of those initialization problems, because if you have a test that goes and tries to touch every button, then if one of those doesn't exist, it'll obviously fail. But some unexpected in the field, this thing didn't exist when I was sure it was going to, that's probably some time when you're going to want to do fatalError or do something that triggers some logging. And then the question is when, because you probably don't want to override the getter for every single outlet in your app and do something if it happens. One potential way to do it would be in view.did_load. Just go through, give it an array of outlets, and if any of them are nil, then throw some error up. Maybe tell your coordinator that there's an error in initializing it, and then the coordinator could treat that as like an invalid state that it couldn't enter some view controller. So spoiler alert, if you didn't go see Paul's talk about coordinators, you should, because they're very useful when presenting errors.
Okay, do we have any more questions? So maybe please continue.
Yep, so I'm going to continue on. This is the last slide that's only about errors. I want to talk more about this table view example, because this is where I feel like making it more generic makes it a lot more readable. So first off, I'm going to set up a couple of protocols. We're going to have reuse identifying, which is just a thing that has a reuse identifier. And then we're going to set up nib creatable, which is going to have a nib name and a bundle. And then you can make a nib with that nib name and the bundle if you are nib creatable. And so this is for the case where you have some nib in your app that is a table view cell or is a header footer view that can be reused, and you want to register that with a table view. So we're going to have this extension on UI table view, of course, called programmer error. And I have two cases here where these are unregistered, either for the cell or for the header footer view. And then there's this method, reusable table view cell. You give it some type, that's a table view cell, that's reuse identifying. And then it calls this dequeue reusable cell with identifier. And if that doesn't give you a cell, it will call unregistered cell. And the reason for that is that you have to register the cell before you can do this. And so I have a test that makes sure that when my view controller loads, after viewDidLoad is called, then this cell has been registered with the table view for reuse. And same thing with header footer views. Obviously, if you're using storyboards, this is going to look a little different. You won't need to do the registration step if you have prototype cells in a storyboard. And this is just going to be the same exact thing, but different method names because it's a different thing. And then we're going to have some registration methods for these cells. So if a header footer view is nib creatable and reuse identifying, then we can register its nib for the header footer view reuse. And for a cell, all we need to do is pass in the class. So now, inside of our cell or header footer view returning methods, all we do is give it a type, like switch table view cell, and then we say try table view.reusable table view cell. And because the compiler knows what type I'm expecting, it knows to look at that, make sure that it's all working well, and if it doesn't get one, then it throws the error. Same thing with the header footer view. So this, I think, is a much cleaner way to handle the error, and it's very type safe. It's hard to make a mistake, and I've enjoyed using it a lot so far. So that's all I have for slides. If there's any other questions, go ahead. Otherwise, thanks for coming to the talk.